Welcome to this lecture on conducting full structural equation models. As I talked about in the intro video, today is all about bringing together everything you've learned this semester and doing an actual full structural equation model with both latent and manifest variables. We're going to use an example today. In our example today, we're actually going to use Lab 2 data back from multivariate statistics. And I'm going to repurpose that for our example today that we'll be doing. So I've created a document for you, which you'll see, and a number of documents that you'll see in the beneath the lecture in this module. These different files will be used for different parts of this example. This first one is the Word document, and in here I've kind of outlined a quick summary. Now this isn't exhaustive, but a quick summary of the different steps that you'll do from the very beginning to the very end. So we're going to start off with developing hypotheses, and we're going to work on conducting our preliminary analyses, getting the SPSS file ready for M+, testing our model, and then writing up our results. So we're going to go all the way from the very beginning to the very end of actually conducting an SEM analysis. So this starts with developing a hypothesis. So like I said, we're taking the data from our Lab 2 and multivariate statistics and repurposing it for this and using the same variables we use in that lab and conducting a structural equation model. And this data actually does come from the Fragile Families data set, so it is real data that we are using in this example. So we start off with this by developing hypotheses and then specifying a model and then identifying that model. So let's start with our hypotheses. So for our example today, I've developed 3 hypotheses. We are hypothesizing that relationship quality and parental engagement, so the better the relationship quality and the more engaged you are with your child, the more quality time that you will spend with your child. So relationship quality and parental engagement are significantly associated with parental quality time. You've noticed in our hypothesis we've removed all causal language. We're using our correlational language, linked with, associated with, rather than saying impacted or affects. But essentially we're hypothesizing that relationship quality and parental engagement are going to impact or predict parental quality time. And our second hypothesis is that parental quality time will be linked with negative child behavior. So the more that you spend quality time with your child, the less negative child behavior there will be. So we're gonna hypothesize that parental quality time is significantly linked with that. The third hypothesis is that relationship quality, parental engagement, and parental quality time are significantly associated with negative child behavior. Now we anticipate those to be negative associations, and if we want to be more specific in our hypotheses, we could state parental quality time is significantly linked with fewer or less negative child behavior, but I'm going to leave it this for the purpose of this example. Now the next thing we ought to do is take this and specify a model from our hypotheses. What I typically start with is I start with a conceptual model. This isn't necessarily the SEM model that I am going to be testing, but it's going to help build a step towards that by drawing out conceptually what I'm hypothesizing here. And if we take these three hypotheses, the conceptual model we get from that is this one here. So relationship quality and parental engagement impact parental quality time. That's our hypothesis 1. It's these 2 arrows here. And then our second is that parental quality time impacts and is associated with negative child behavior. And then our third hypothesis is that all 3 of these impact negative child behavior. Now realistically, this is actually a mediation model where parental quality time mediates the relationship between these 2 sets of variables. However, because we haven't covered moderation or mediation, I'm not going to be doing a mediation analysis in this model. I'm just going to be doing the straight SEM model without any mediation analyses. Now if we take these and move this into a full structural model, what I'm actually going to be doing is having our exogenous variables, relationship quality and parental engagement, as latent variables in our model. And so when we draw out our tested model, the model that we are actually going to be testing is this one here. So we have relationship quality and parental engagement as latent variables. Relationship quality has 6 manifest variables, so 6 items that make up relationship quality, and parental engagement has 5. And then we're going to keep parental quality time and negative child behavior as manifest variables. I could do the same thing with these and make them latent variables. However, for the purpose of this example that we're going to do, because I want to have latent and manifest variables in the same model, I'm going to be testing it in this way. And you can see we correlate our exogenous variables, and this is our tested model here. We can see that this is a completely recursive model, so there are no feedback loops, there's no bows anywhere in the model, and this is the model that we're going to start with. We'll see if it's the model that we end up with by the end of it, but this is what we're going to start with. So we have now, come on, there we go. So we have now developed our hypotheses and specified our model. Now we need to assess model identification. So let's go ahead and go through and test our model identification. We're going to start with that by calculating out our total number of observations. Oop, wrong place. Let's go down to our tested model. There we go. Total number of observations. So we do our observations by p times p plus 1 divided by 2. So let me grab out my calculator, and let's count this up. So we have 6 and 5 manifest variables. Remember, we don't include our latent variables. We're just looking at our observations. So we 6 and 5, that's 11, 12, and 13. So we have a total of 13 manifest variables in this. So we're going to do 13 times n plus 1, which is 14. That gives us 182 divided by 2 gives us 91. So we're going to have 91 total observations. And then the next thing we're going to test is our variances, covariances, and direct effects. Because that's going to give us our total number of parameters. All right, so variances, covariances, and direct effects. Our total number of covariances, we only have one covariance in our model, so that one's pretty easy. There's one. Direct effects, let's count up our single-headed arrows. So we have 6 here and 5 here, so that's 6 and 5 is 11, 12, 13, 14, 15, 16. So we have a total of 16 direct effects. Now let me just double check this. So we have 2, 4, 5, 10, 16. So 16 total direct effects. And then variances, I didn't actually draw out the error terms, but our variances are our residuals plus our exogenous variables. However, our exogenous variables are latent variables, so we don't include it this time in this analysis. So we're going to have 5 and 6, so that's 11, and then 12, and then 13. So we'll have a total of 13 variances. So if we add this up, we'll have 13 plus 1 plus 16. That gives us a total of 30, and then if we subtract 91 from that, we get a total of 61 degrees of freedom, which means that we are going to be just fine in this analysis and be well over-identified. So this should be empirically, we should be able to empirically validate this model when we test it. All right, so we've now covered step 1. We've developed hypotheses, we've specified the model, and we've assessed model identification. Now we're ready to conduct preliminary analyses. So we're going to clean the data first. I've cleaned this data previously, most of it. I've gotten rid of unnecessary variables. I haven't created composite variables yet, but I've already done a lot of the cleaning pieces. So we're going to go ahead and clean our data, test our assumptions for structural equation modeling, and test Cronbach's alphas for both the composite and latent variables. The reason I'm going to test the Cronbach's alpha for the latent variables is because, one, you'll often find journal articles or reviewers will ask for your Cronbach's alpha for any latent variables anyway. And 2, it's going to help give us an indication of whether that latent variable is likely to work or not. Because if you have a really poor Cronbach's alpha, you're probably not going to have a good model fit for your latent variable. So we'll go ahead and do those first. All right, so here we are in our SPSS file. We have the variables here. I've already renamed them from what they were back in Lab 2. So you can see I've renamed them to make much more sense and make it easier for me to follow them. So I've renamed the negative child behavior items as neg-BE, so negative behavior, 1 through 9. Parental engagement, 1 through 5. Relationship quality, 1 through 6. And then our parental quality time, 1 through 3. Okay, so the first thing that we're going to do is we're going to test some of those assumptions. And we're going to do this first by looking at our descriptive statistics. So we're just going to pull all of our variables over, and then we're going to make sure that we want to get skewness and kurtosis, We don't need we can check out the variance, make sure there's variability in there, and then we check our mean and standard deviations. So I'll go ahead and paste that over onto my syntax window. There we go. And real quick, one thing I'm going to adjust in here is, it looks like we got a good, all right, mean, standard deviation, variance, min, max, kurtosis, and skewness. We got all our variables in there. So we can go ahead and run that. And if we open up our output window, there we go. So we have the n here, the minimum, maximum, the mean, standard deviation, the variance, the skewness, and the kurtosis. So first let's check our normality, skewness, and kurtosis. So 3 and 10. We want our skewness to be below the absolute value of 3. And if we scroll down here, we can see nothing goes above 3. And then this one for 10. We can scroll down here, and nothing even comes close. So normality, we're good for all of our items. We can see that all of our negative child behavior items are between 1 and 3. We can see that our parental engagements are between 0 and 7. Our relationship quality are between 1 and 3, and our parental quality time is between 0 and 7. This is going to be important later when we get to our creating our composite variables. So we look good there on skewness and kurtosis. The next thing I'm going to do is check my correlations. And I'm going to do this by doing several different correlations. I'm going to do the negative behavior, the parental engagement, the relationship quality, and then the parental quality time, one at a time, and make sure that, one, I have adequate correlations to be able to combine these together. So we want to see a number of sizable correlations and significant correlations. 2, double check I don't have anything reverse coded. So if in my correlations table I have any negative values, I've forgotten to reverse code something. So we're going to go through this and do this one at a time. So the first thing I'm going to do is go to Analyze, go to Correlate, and bivariate to my correlations table, and let's check out our negative behavior first, or negative child behavior. If you go to Options, you can do have different options there. I'm going to do list-wise, so I have the same p-value for all of them. And then I'll go ahead and run this one. And as I go through and look through this, I see there's a bunch of significant associations, which tells me this is good. These should work well as, this is another sign that these should work well as a composite variable or as a latent variable. And I look through and I do not see any negative signs. So that makes me feel good. Let's go ahead and go to our next one. So go back to Correlate, bivariate. We'll throw our negative child behavior back, and this time pull out our parental engagement. Let's take a look at this one. All right, no negative signs. We've got some good size correlations and some significant correlations, so that makes me feel good. Let's go ahead and go to our next one, relationship quality. Now let's go ahead and check this one out. All right, relationship quality. We have some good size correlation, significance, but we have a negative sign here. And it looks like this is relationship quality 3. If we see this is negatively associated with each of the other variables, and any other negative signs we see here are about relationship quality 3. So this one was not reverse coded, and it should have been. So let's take a look at this item to kind of see what this looked like. And we can see for relationship quality 3 that this item is actually asked in the opposite way, where all the other ones are about expressing affection, encouraging, and helping. This one is insults or criticizes you. So indeed, this needs to be reverse coded. If we click, wrong one. If we click on our values over here, we can see that it's on a 1 to 3 scale. So we're going to go ahead and reverse code this. Go to our syntax window. I can make a little note here about what I am doing. Reverse coding RQ3, which asks about criticism. So I'm making my little note there, and then I'm going to say recode. And I'm going to do RQ3, and I want to do, we're going to do, this is what I do in order to kind of make it work quick and well. So it goes on a 1 to 3 scale. So 1, 2, 3. Put in our equal signs. 1, 2, 3, and then count down. 3, 2, 1. All right, so we have RQ3 being reverse coded here, where 1 is 3 and 3 is 1 and 2 stays the same. So we can go ahead and do that. And then now if we rerun our correlations table, we can now see that for RQ3, that negative sign is gone. So we just avoided a potential blunder by taking our time and looking at our steps and paying attention to the results. We were able to see that there's a negative sign in there, indicating that we had an item that was reverse coded, because these should all be going in the same direction if we're going to be combining them together. So that makes me feel good that we were able to catch that error rather than finding it much later down the road. All right, so relationship quality has been taken care of. Now we need to continue on here and check our last one. So parental quality time. So let's go ahead and check that one out, and we can see good size correlations, and also they are significant. And when I say good size correlations, I'm looking at like above 0.2, 0.2 to 0.5 is pretty good, and also that they're significantly associated with each other. So that's all good. So now what I can do next is create my composite variables. So let's go ahead and go back to the syntax window, and we're going to do compute. I like things all caps. You don't have to have it all caps, but it just makes me, it looks a little bit better. So, and I'm going to make myself a note here that I am creating composite variables. I'm going to do the mean method for these, using mean for all 4 study variables. All right, so the first one we're going to do is negative child behavior, and we're going to have that equal to mean, and then we're going to do neg behave, and I'm going to show you a quick way to do this. So I'm going to copy that. I'm going to go 1, paste 2, paste 3, paste 4, paste 5, paste 5, paste 6, paste 7, paste 8, paste 9. Remember, work smarter, not harder. All right, and then execute. And we're going to continue this for the rest of them. I'm going to go ahead and skip the video ahead to where I've created the syntax for all 4 of these. All right, so I've now created all 4 of my composite variables. I have negative child behavior, which goes 1 through 9. I have parental engagement, which goes 1 through 5. Relationship quality, which goes 1 through 6. And parental quality time, which I'm going to call qual time, 1, 2, and 3. So I'm going to go ahead and create those 4 variables. There we go, 1, 2, 3, 4. And if we check our data window over here, we can see that they have been created and have values. So now I'm going to do the same thing I did with the other variables, where I'm going to first check the descriptives, and then I'm going to check the correlations. So descriptive statistics, I get rid of those that I'd used before, and I'm just going to add in my 4 composite variables. Options have stayed the same, and so I'm ready to check those. Now we can see that indeed our negative child behavior goes on 1 to 3 scale, just like it should, and 0 to 7, 1 to 3, 0 to 7. So all of the scales are as they should. If you remember, if we go back up to the top, we can double check what the scales were on those variables. So there we go with that. Our skewness and kurtosis look good, nothing above 3 or 10. And then we can see our means, we have good variance, we have adequate numbers, we have people with responses for those, about 1,000 for all 4 of those. So we're looking good there. Now we can check our correlations table. There are the 4. We'll pull those over and run that correlations table. So we can see, now in this one, I don't care if we have negative or positive. In fact, we should hopefully see that negative child behavior is negatively associated with parental engagement, relationship quality, and quality time, which it is, and we can see that they're significant. Now this normally if this was not a class example, if I saw this 0.91, I would get worried about this because that's an indicator that it might be the same variable. When we look at quality time and parental engagement, it seems that it's measuring the same thing. So at this point, I would reassess my model and consider this because of that really high correlation. I may also just run a simple linear regression and check out my BIFIN tolerance for those two variables. So I could run a quick linear regression that has quality time and parental engagement with negative child behavior as a dependent variable, check BIFIN tolerance, and see if that indicates that it's the same variable, and then make a decision. However, for the purposes of this class, I'm going to move forward so that we can continue on with the SEM example. All right, so going back and double checking what I've done so far. So I've developed my hypothesis, conducted most of my preliminary analyses. I am now ready to, I've cleaned the data, tested my assumptions, and now I'm ready to test Cronbach's alphas for my composite and latent variables, or what will be measured as latent variables. We're not going to be using these ones I created in the analysis, but I'm doing this so I can check some analyses, preliminary analyses before I get to the actual SEM model. So let's go ahead. We're going to go over to scale and reliability analysis. And the first one we're going to do is negative child behavior. So I can pull those over, just those first 9, and we're going to call this negative child behavior. We want Cronbach's alpha. And there are some options. If you click on that statistics window, let me pull that window back over. There we go. Where we can get correlations, covariances, means. We've already tested all those. The only one that I might be curious about is the scale if item deleted. So I'll click on that. And I'll go ahead and paste that. And then continue through creating scale. There we go. The rest of my, so there's negative child behavior. Here's parental engagement. Oh, I hit the correlations window. There we go. All right, parental engagement. Now relationship quality. I'm hoping you see too that by renaming these variables, it makes it much quicker to do this because it's easy to find these variables. It makes it easier to compute your composite variables. Everything becomes much easier. And this last one is quality time. So I can go to my syntax window, and I've got my 4 reliability analyses here. I can make myself a note of testing Cronbach's alpha for main study variables. All right, so we've got negative child behavior 1 through 9, parental engagement 1 through 5, relationship quality 1 through 6, and quality time 1 through 3. I am ready to run these. All right, so let's check these out one at a time. So 0.75 for negative child behavior. It's a good Cronbach's alpha. Happy with that. I don't need to worry about looking at removing anything. 0.69, again, about 0.7. It's decent. Could be better, but it could potentially work. And we can see here that even removing anything doesn't really help with this Cronbach's alpha. So we're going to keep them all in. And then here's relationship quality, 0.76. So again, adequate Cronbach's alpha, and again, no way to kind of improve that based on those. And our last one is quality time, 0.56. This one's pretty poor. So this one I would look at either seeing how it would fit for a latent variable, which I don't think it would work very well, or I'd want to just keep these items separate or reassess this. And if you remember, quality time and parental engagement were pretty similar, so I'd probably just drop quality time. But for the purposes of this example, we're going to pretend that this is high and continue on. All right, so before I move on, I want to make sure I save these output windows. So I'm going to take this, I'm going to save. I'm in my right folder here, datasets for practice, and I'm going to say this is my full SEM model practice output preliminary analyses. So I've got my output saved. I can close that down. I want to save my syntax as well. So I'm going to save my syntax in the same name. This is not the right folder, so let me go back to my Dropbox. I go to, where are you at? Structural equation modeling class. This is my data sets for practice under my full SEM model, and this is full SEM model example syntax. All right, syntax is saved. I would also update this, so I'm going to go save as, and full SEM model examples, data cleaned and prepped. So now I've saved my data set as a new file name, just in case I made mistakes and need to go back to the original one. I've saved my syntax file and my output file. We're ready to now go on to the next step. So the next step is to convert this file and have it M+ ready. So the first thing we're going to do is fix the missingness, and then we're going to go ahead and save it. So to do the missingness, we're going to go to transform, recode into same variables. We're going to grab all of our items except for our participant ID. Our participant ID is that first variable. So we're going to grab all of these, including our composite variables. Click old and new values, and we want all system missing or user missing, any of those, and then we're going to recode those as -99. I like -99 because it sticks out as a sore thumb. It doesn't matter what you put on it. So we'll go ahead and hit OK there. That went ahead and ran. And we can go over to our data view and see all of these -99s in here. And if we want to be double sure that this worked, we can grab all of these variables. There we go, grab all of them. Right click, and you can ask for descriptive statistics real quick. And in here we can go through, there should be a table at the top, there we are, a table at the top, and we can double check that we have how many valid we have, how many missing we have. And it says here minimum is -99, maximum is 3. So there's an easy reason why this is looking this way, and that's because over here in our missing it still says this -1 to -14. So if we just changed this to a discrete value of -99 and then copy that and paste it through. We just highlight them all, paste it through, and let me check this one more time. Grab all of them. Check our descriptives. Go to that first table. There we go, that looks better. Now we can see how many valid, how many missing we have, and we can see that the range of the variables, the min and max, all look accurate. And so at this point we have recoded this, ready for M+, and now we just need to save it. So I'm going to resave this data set, and I'm going to save it as M+ ready, because I've resaved, because I've recoded everything, all of my missingness to one single value. So now I'm ready to create my M+ file. So again, I'm going to go to Save As, and this time I'm going to make it a .dat file. My file name is going to be full SEM model practice M+ file. And I'm going to uncheck write variable names onto file. So there we go. Now this is all ready to go. If I wanted to, I could delete more variables before I do this. I'm going to keep them all in here because there's not that many here. I'm going to go ahead and write file, write name, tab deeliminated, check mark undone. So I've double checked myself. I'm going to go ahead and save this. And now if I check my folder, I'll pull this over to check my folder, You can see I have my data set here, and if I wanted to open this up, I can see that there's no variable names on it. This is ready to go for M+. So we have now developed our hypotheses, conducted our preliminary analyses, converted over to make it M+ ready, and now we are ready to test our model, and we're going to start with testing our CFA.